All right, guys. So unfortunately, because of Labor Day, we won't be having our first module together. So I decided to make this video. It shouldn't be too bad. This module is just about graphing relations, and we'll kind of show a few tricks on how to do that. So our objective for this lesson is going to be identify variables in real world situations and model those relationships graphically. So we're going to figure out the relationship between two things, usually between an x and a y. X usually being what's called our independent variable. So independent variable, this is something that we really have no control over. It doesn't really affect things, or I should say, it's not affected by things. So that's why it's independent. It's not affected by things. Like, so for example, time. No matter what happens, time's still going to go on. Our y is known as our dependent variable. So that is affecting things. So for example, like temperature. Temperature might be affected by time. So we do have to kind of, it is a dependent variable. So it's basically a relationship showing how the deep our y is affected by the x. So we're going to see how to model these functions. So our main relationship that we'll see the most often is a linear. I didn't show the table of contents, but linear transformations piecewise. This is like when a certain piece of the function follows certain rules. Um, Piecewise linear, so they follow different lines. Different pieces follow different types of lines. So if I look here, it's saying, so Brianna's excited. So let's see what Brianna's excited about. She was hired to work to babysit on Saturdays. So she's earning extra money. So her family pays her $12 every hour, $12 an hour for a maximum of 8 hours. So Brianna works a table to show her work. So if she works 5 hours, how much does she work? Well, we're going to have to do this 12 times 5, right? And that's going to give us 60. And then it's like, okay, well, so that gives us 60. But this other one, it's going to tell us at 72. Well, how many hours did she work? Well, that's when we're going to put a little variable here. Let me change these. I don't like how I'm using the crosses because, so it's going to be multiplied by 5. So what did she work? X times what? So we would have to divide by 5. I'm sorry, divide by 12. 12 times how many hours? I took the wrong thing down. So we're going to have to divide by 12, and we'll find out that if I pull out a calculator here, oh, perfect. I get 6. So I'm going to get a 6 right here. Now, one thing you might notice is that, wait, we keep going up by 12. So if I do 7 hours, I'm just going to add another 12, which is 84. And if I look here, I'm like, oh, wait, it has to be 8 because she could only work 8 hours. So what's happening here is we're noticing a rise over run. This will make more sense when we're graphing it, but our rise is $12 and our run is every 1 hour. So $12 for every 1 hour. That's what's known as our rise over run. Every time I go over 1, I go up 12. I rise 12. And we'll see how to represent this in a graph. So we've already kind of described how to say it in words. We've already shown the table. Now we're going to show how to graph it. So linear representations. So as I mentioned before, there's this idea, this rate of change. This rate of change, if you look here at the definition, it says ratio. what is that ratio? That ratio is our rise over run. In this case, 12 for every 1. So $12 for every 1 hour. That's the relationship here. So let's kind of take a look at this. So again, we're going to do this here so we can do our independent variable. Our independent variable, like I said, it's a quantity that changes freely. We can't determine it, but it might affect other values. Our dependent variable, if we look at the definition, is a quantity that changes in response. It's being affected by another variable. So that's why we get this. Our domain is everything we can work. She can only work from 0 to 8 hours. So that's what's known as our domain. Domain goes with X, and we're going to learn that our range goes with Y. I would remember this as ABC order, alphabetical order. Domain comes before range. X comes before Y. Easiest way to remember it. And our range, it's like, well, in order to find our range, we have to find the most money she can make. Well, if we look at our chart, 8 is the most hours she can work, so times 12, so our range is she can make no money all the way to $96. And again, we can watch this video about rate of change on your own. I'm not going to spend 3 minutes of this YouTube video on that video. So if we see here, our rate of change is our rise. Remember how I said rise? So rise is known as the change in Y over the change in X. The change in X is known as our run. So another way of saying this is we take our second Y, so this Y value here, 70. We take our second Y, this is supposed to be a Y2, by the way, minus Y1. So we take our 70 minus our Y2, or Y1, sorry, which in this case would be the 60. And we're going to divide that by our X2 minus X1. So in that case, if I look at my second point, my X would be 6. And I'm going to subtract that from my X1, my first X, which is this, and that's going to be a 5. And we see here that that's going to end up being, this will be a 72. 70, it's a little bit higher than 70. I forgot about that part. 12 over 1. And this works with no matter what numbers we're doing. So let's say, for example, I chose this to be my first point. And I chose, I'll do it in white, this to be my second point. Well, if I did that, I would end up getting this 96. It's a little weird to see, but remember from the chart it was 96. Our X that corresponds with that point is 8. And then I'm going to use this minus 60 from right here, minus the 5 hours that were in that chart, so minus 5. This would end up giving me 36 divided by 3, which is way different than 12 over 1, or is it? Well, if I do 36 divided by 3, I get 12 over 1. It's the same thing. Even though it's a higher rise over a longer run, the ratio is still 12 over 1. I'm not sure if we're going to get into that later, but I wanted to discuss it. So we can work through an example. Again, try this on your own that we can see it. I'm not going to spend another 3 minutes on that video. So if we look here, which statement can be stated about this? Again, I really wish they would default it to unanswered, but the relationship we can say is the number of pounds depends on the total price. Well, pounds doesn't depend on it. This is independent. Pounds is independent. So that can't be it. The number of tomatoes, the number of tomatoes on the goods of pounds depends on, well, none of these says number of tomatoes. We're talking about dollars and pounds, so that can't be true either. The price depends on the number of pounds. Well, yeah, or why is there? And I know it showed it earlier, but let's see why this one. Total price depends on the number of tomatoes. Again, we're not dealing with number of tomatoes here. So that's why C is our answer. And I just realized I closed my pen. All right. So, oops. What's going on here? All right, cool. So when we're doing this, so Brianna is saving money. She wants to save $50 every week. I'm sorry, $15 every week. But she already started off with 50. So this is going to be known as our Y-intercept. It's what we start off with. When we're dealing with a linear function, there's this formula called y equals mx plus b, where m is the slope and b is our y-intercept. Our y-intercept is also known as y value when x is 0. To put this in another way, think of this as a line y equals mx plus b. M is how we move, our rise over run, and B is where we begin. So she starts off with $50. See how it's the Y value when X is 0? So I'll leave that on screen for like a little bit. But then we can see here that she goes up 15 for every 1. She goes up 15 again for every 1. So that means our M is $15 for every 1 week. Dollars per week. $15 for 1 week. So let's see how this would be graphed. So if we graph it, we have to start right here at 50 because that's where we're going. And this is known as discrete. Most algebra classes don't talk about this, but this idea of discrete means that it's only made up of points. She doesn't have like $60 sometime in the middle of week 0, week 1. It just starts off, it just jumps. It kind of just jumps over without having a straight line. So that's what it means to be discrete. Just this idea of they're just dots that happen to make a line. So our rise over run, everything's still the same, except we just don't have a line connecting them. Continuous, that's if like every day she was getting money, every second she was getting like a little bit of change or something that made this line happen. So we can tell that it's gonna go up at this rate and it could be represented by a line, but in reality it's not. That's why it's called discrete. Continuous meant she's constantly being given money like every second of every day. So at any point in time, we can pick it in the middle. All right. So now we're going to be talking about our domain and range. So since this is discrete, our domain is only specific points. Our range is also specific points. So it's not this whole like y, our x values are every possible number, including fractions like this. It's like, nope, it's only these specific numbers, meaning that our savings is only these specific numbers. You don't ever make like $60 or $55. It can only be those. All right, so here, the relationship describes what? So it pounds per dollars. So the relationship is, in this case, can you have a fraction of a pound? Yeah, you can. It's not like you can only buy it in half pounds. You can buy it like 0.75 pounds. So this is continuous because you can have little things in the middle of these two. It's continuous. The domain is the relationship. Um, so you can't have anything less than zero. So x greater than zero makes sense. And it's not discrete because these aren't our only options. We have options in the middle. So anything greater than zero. And we write this as x is greater than zero. Greater than or equal to, because it can be zero. The range, again, this is continuous. So we would start off with y values greater than or equal to zero because you can either get nothing or if you get a little bit of pounds, even a little bit of almonds, pounds of almonds, a little number of almonds, you get like a little decimal of dollars. So that's where we're getting these from, is because you can have decimals in the middle. It's not like only half pounds. So piecewise, this is the idea where we kind of have, you might have seen it before, like, oh, if you're under so many people, it's this price, but then if you're over this many people, it's cheaper per person or something. This is what's known as piecewise. From a certain point, a specific x value to a specific y value, it's a certain rate of change. But after you reach a certain benchmark, the rate of change is smaller. You can see that that slope is a lot smaller. Let's see which examples they have for us. So you can see right here. So what's happening is this has a greater rate of change than this part, than this part. The rate of change keeps decreasing. So our slope decreases after certain points. In this case, this right here, this is a different function. That's why they call them piecewise functions. It has different pieces. It has functions for different pieces of the graph. So again, you can watch the example. This one's only 20 seconds, but still, we keep moving forward. So here, what's happening is they want us to recap on what happened in the video, so you can watch that again on your own. So here, from 0 to 6, it's going at that rate. But then, if we look over here, from 10, looks like they stopped. They stopped moving. So this is a different piece of the function. And then from here to there, it looks like they went back home. They finally ran back home. They're like, I'm done. I'm just going to decrease. So this is the distance away from home. So they like ran really fast and they're like, they stopped and they're like, you know what? I'm just going to run back home. And they ran back faster than they did there. It only took them 3 seconds to get back home, but it took them 6 seconds to get there. So you can see that the slope is a lot bigger. And then here, what we can show here is like, look, this area, at first, what are we doing here? When you're first buying the blueberries, if you're not buying that much, if you're buying like, it looks like under 5, it's expensive. But if you start buying over 5, it looks like they're giving you a discount. And if you buy even more than 11, I'm guessing, I'm going to guess 11, they give you an even steeper discount, so it becomes even cheaper. Click each spot on the graph to learn more. So if you click this, it's like, oh, look, it's $25 for the first 5 pounds. And then anywhere after that, it's $2 for that. So that's why it's not as steep. And then after that much, it's costing you that this much. So that's why the slope just decreases a lot. So let's check this out. So if we're looking at this graph, we're going to imagine Brianna's traveling to get to her babysitting job. Describe the relationship. So it looks like at first she's traveling, she goes only so fast, and then she stops. And then she goes again. So she stopped somewhere. So imagine the relationship, describe the relationship of the graph they represent. So at first, Uh, Brianna is walking at walking to the job for, let's say, 6 minutes. Oops, not 5, 6 minutes. 6 minutes she's walking to her job, her babysitting job. And then for, looks like we're going from 6 to 10. So for 4 minutes, 10 take away 6 is 4. For 4 minutes, but then from 10 to 16 for the next 6 minutes, because 60 minus 10, 6 minutes, she jogs to the job, which was 7 miles from where she started. Okay, so what I'm saying here is the reason why I'm saying she's walking is look at this rate of change. It's a low slope, but then it looks like she went faster, so she like stopped and like was probably in a hurry and started rushing, right? And the reason why I said it's 12 miles from where she started is 0 is where she starts. And this, oh, I said 12, I meant to say 7 miles. This is 7 miles. So her big job is 7 miles from where she started. Where did she go the fastest? Here. That's where the slope is the fastest. Um, on part A, in this situation, time is the independent variable. And time is usually going to be an independent variable. You can't really control it. Distance is the dependent variable. How far she went depends on what time we're talking about. How far is she? It depends what minute we're talking about. And then just describe how you felt about this, guys. Difficulty. I think this one's pretty simple, pretty basic. Uh, Use your own words when describing the situation. Let's take a look at 24. I feel like I'm going to have to pause the recording to reload this. I'm going to pause the recording real quick, guys. I figured I'd pause just because it saves some time in the video. So that was pretty much it for this lesson. Let's kind of go over the summary. And again, guys, always review your summary when studying for these mastery tests. It's just a good idea. The relationship shows the difference from the pair. So we're talking about x values and y value. Just remember your x value is always going to be your independent variable. And then our y value is going to be our dependent variable. And the domain represents all possible independent variables. So everything here. So if it's discrete, they're going to be little dots. So the numbers in the middle won't matter. Our range represents all y values that work. All the y values that work. Discrete. So again, discrete. See how not all the x values work? So 1 would work, but like half of 1 wouldn't work. So this is discrete. It's just a set number of points. And piecewise means that our slope changes. Non-overlapping means you're not going to have like a line right here in the middle. Let me draw that. You're not going to have something like this. Otherwise, it's not a function because this x value would have two answers, one right here and one right here. So non-overlapping. It cannot overlap. And that's pretty much it, guys. Hopefully you guys enjoyed that. I'll try to get this up as soon as possible, and I'll remind you guys about this. It won't be due till Friday because I know you guys are finishing up your unit ones, and this is going to be tough because it's on the day that we didn't meet.